Okay, so this is just a discussion on these things. So the homework and the mini project. All right, so the homework, just start working on it right now. You guys don't have the GPU yet, so I don't really want to assign the homework. As I said, I did create the thing on Scholar, and then hopefully we'll have to try it. Hope that works. I know some of you have GPUs, so for some of you, this might be easy. But the GPT is this example here. I actually have a new one. So I didn't link it, but give me a sec. So I'll add the link later, okay? But I'll show you where it is now. I have it here somewhere. Here. So all right, so the link is going to be here, deep learning algorithms. And go to chapter 10, transformers. And it should be this one, GPTs. I'll add this link later. All right, so I was playing with this actually the other day. This is the code that you're going to use for your homework 1, right? Homework 1. You don't really have to change this code. It just works. But this is a GPT from scratch. Okay, so it's not, so the project will use HuggingFace. The homework will look at a GPT from scratch in pure PyTorch. So there's no HuggingFace. For those of you, as I said, that took 520 with me last semester, you've seen this one lecture. I showed this to you and I described it really quickly. This time around, in 530, I always have the students train their own GPT, okay? So the way that this is going to work is you can see here, for instance, I have an example, which is what I'm going to run today. I have HuckFin. I got this from the Gutenberg library. So this, Gutenberg.org. So this should be the adventure, from the project Gutenberg, should be the adventures of Huckleberry Finn. Okay. And you can give it one book, or you could give it all the works of Mark Twain. Right? You could do that, or you could give it all the works of Shakespeare, right? Or you could just give it Macbeth, or some other author that has written several things that might be available publicly, right? So the Brothers Grimm, Beatrix Potter or Anderson, something, right? So fairy tale stories, whatever you want to do. So the homework will be very simple. You just have to pick a set of text, right, of books, or if you just choose one book, obviously your model may not be as good. The more text you give it, the better it'll be. However, the more text you give it, the more processing time, right? So I trained this on my GPU. I have an RTX 2080 Ti, and it took me about 20 minutes to train on Huckleberry Finn, I think. Probably less. Okay, so 10 to 20 minutes. So for this homework assignment, if you did this on CPU, let's say on your laptop, because it might take 24 hours, I'm not sure, or maybe not 24 hours, right? But overnight. So you may be able to do it on your laptop, it's possible, but you'll probably just do it with one book. If you use a GPU, the advantage is you can give it 20 books. Right. And at the end of the day, you're going to want to see how good it is at doing the task. So in this case, it's going to be a GPT, right? So GPTs are like ChatGPT. They generate text. Okay. You give it a prompt and it generates text. What I like about this example is because it's from scratch, it actually takes away some of the abstraction of HuggingFace, right? So HuggingFace is doing some things in there, so we don't know quite how it's doing things. Whereas here, you can actually see, oh, I can give it a prompt, and it's going to give me the text, right? So that's the idea. I was actually running some examples. Anyway, so that's one thing. So is that clear for everyone? Do you guys understand? So the homework is start thinking of a subject. So in the past, students did Harry Potter. I have no idea how they got the text for that. They did, I think they did Harry Potter. Oh, what's this show, cartoon show? South Park. They did South Park. So that you know that you can do whatever you want. Certainly, you can get a lot of books from the Gutenberg website that are free. That's where I got this Huck Finn. So I have two examples here. They're basically the same Jupyter Notebook, I think, but just one is for Huckleberry Finn. So I'll discuss as I did in 520. I'll go over this code in a lot of detail. The nice thing about understanding a GPT is you basically also understand a BERT. There's just like small differences here and there, so you get it because when you look at a transformer, you have the encoder and the decoder, but they're actually very similar. There's just like very small differences here and there, and so you know I used to think, let's understand the whole transformer, encoder, decoder, all working together. And that's actually a bad way of approaching. You want to instead understand the GPT, right? Then understand the BERT, which you basically do already if you understood one, and then start thinking about how they would be incorporated into the actual transformer. Got it? All right, so this, as you can see, is pure PyTorch. It's got the standard libraries that you're familiar with from 520. I won't go through all the details here, but you can see this is where you load the file, okay? And then I will do this some other time, but this is similar to what we did in 520, where we looked at creating our own tokenizer, right? And this is a tokenizer from scratch, very easy to understand because there's only 26 tokens, which are just the letters in the English language and a few symbols, okay? So that's, I'll cover this later, but basically that's all the code. Then you have the NN architecture, so the transformer. I think, as I said in 520, the thing that allows us to code these things, because it's really complicated today, is we take an object-oriented approach. If you do that, it actually becomes manageable, right? Because you create an object, a class for, you know, layers, and then you can have 6 layers, and it's, you know, they're all the same. And then you can do the heads, attention heads, and so on. So this is what allows us to understand things. Now, this coding that you see here is actually very much, it's a little bit high level. There's actually lower level ways of coding this in PyTorch. So it's actually more, it's simpler in a sense. All right, so I'll cover all of this, but if the main classes are the head class, the feed forward layer, which all of you pretty much know this one by heart, the multi-head attentions, right? You can see that there. So you have the heads here, which are this. This is, so the head is actually what holds the attention layer, right? The basic mechanism that is essential in transformers. So please read the paper. That's the first thing. You'll have questions as you start reading it, and then just be aware we're going to talk about this architecture a little bit later, next week, not today. Anyway, for you to do the homework assignment, you don't really have to change this code, right? That's one important thing that I want to stress. You don't have to get in there and modify it. Just use the code as is, and then you change like the inputs and the outputs, right? That's the main mechanism. I have changed the values here from last semester to match the values in the Vaswani paper, and it worked fine. So I made it exactly what the paper has, so this will match exactly. All right. So again, it's got, notice it's just got a head class, the feed forward class, the multi-head attention, which has several heads, and then the block idea, so that you can have several blocks. And then we have our actual GPT model where everything comes together. Okay, so basically this is the thing that puts the whole architecture together from inputs to outputs, okay, which is called the class here GPT model. All right. So anyway, you won't have to change any of that. And then after that, you're able to instantiate your model, tie it to the device, and then you have, you know, your optimizer. And then this is the training loop. I provided here some statistics so that when you run your own training, you want to get something like this. In particular, if you notice, it's going down, right? So by looking at this, you know that you're doing training, right? Now, remember, in the examples that we saw from HuggingFace, we were only doing inference. The weights were set, we were just using them. But here, basically, the weights are what? Random, right, initially. And then with your data, you're training the weights of the model to be able to predict. Questions? All right, so anyway, the paper describes a lot of things, and then I'll start explaining this next week. All right, so once you have that, you can see that you can just generate text. So this is Shakespeare, basically. Okay, so this is an example of one thing that's really interesting is that the article has like this thing, like the character that states something, right? That says something. And the GPT is actually able to also capture that structure. And it sounds like Shakespeare. So it says, thanks thee, you know you well, but among, you know, sounds very Shakespeare-like. This would be better if instead of giving it one book from Shakespeare, I gave it all the books of Shakespeare. Do you see that? It might be even better if I gave it a lot of normal English, like a lot of normal books in English from Gutenberg, and then fine-tuned it on just Shakespeare. Do you see that? That actually is an example of how you train these models, where, because there aren't that many books of Shakespeare, right? But Shakespeare spoke English, I think, right? So he followed some type of grammar, right? Some type of grammar. So that grammar is still in normal books. So you train it with what you have that is lots of data, lots of books in English to capture that grammar. But then you want it to sound like Shakespeare. So you do that. The pre-training is with normal books. The fine-tuning would be with Shakespeare. And hopefully now you have grammar, but also Shakespeare-like, you know, however he spoke. Got it? That's an example of pre-training and fine-tuning, okay? Now, in this example, I'm not asking you to do that. I'm only asking you to build a GPT from scratch, basically. Any questions on that? So this is your homework, and as I said, this should be easy, okay? It's not meant to be hard. If you're having trouble, you're probably overthinking, okay? The code works. You just have to pick the files. You can always cat several files into one bigger file and just feed it that and just give it more text, you know. Okay, so that's one example I have of that for your homework assignment. I did play with this. I was playing with HuckFin book, and I have an example of this idea of prompts and answers, right? So that's something that we all are curious about, right? How does this work that we give it a prompt and then it gives us an answer? So the GPT just like does that naturally. That's what it does. And so this is kind of, it's the same code. This just has some additional inference details at the end. So let's go ahead and take a look at that. So I think this file was not very, it was actually smaller than the Shakespeare one. So it probably took me like 10 to 20 minutes, all right, on a GPU, right? That definitely, I have, as I said, a 2080, and the universities are V100. So a 2080 should be like 80% of the speed of a V100 or something. So they're much faster. All right, so you can see that here. This line of code basically checks to see if you're using a GPU or a CPU, and it just selects the device. So if you're on a GPU, hopefully that's all you have to do. This is linked to the places where you have to tell it to use either GPU or CPU, okay? As I said, later on, I will describe this code. Like one day, one lecture, we'll just describe it in detail next week. But today, I'm just kind of giving you the big picture. I read the HuckFin file here, right, that I downloaded from the Gutenberg project. So I wanted to check that you could download any Gutenberg file that is UTF-8, and it should work. So it's not going to give you any errors or anything like that, and it works fine. Okay, keep in mind that if you grab a different book, the tokenizer is kind of dependent on that book. So The encoder and decoder is gotten from the book itself. So this actually has a different size of the vocabulary. So I think it's 88. So I printed it here, not 65 like in the Shakespeare example. Okay, got it? All right, so you're just using, you're looking for unique characters, basically, right? In the file. All right. So again, I'll describe this later. This is it's pretty much all the same thing. That's all the tokenizer section of the code. And then this is the architecture section. It's exactly the same thing. It's got the head section, the feed forward, blocks, and basically the GPT model that brings all those classes together to create the entire decoder structure. All right, then we instantiate the model there and look at the training again. When you do the training, you want to see this happening, right? So notice 4.69, 195, 184, 179, kind of gets stuck at 173 there, but it's going down, right? So the loss function is going down, which means we're minimizing the error, and that's kind of what we want. Does that make sense? All right. So this is something that is, when you're doing the training, you want to see happening. And then here, we generate some text. So this should be Mark Twain, Huck Finn, actually. So here's an example, just the previous example. You give it one ID, right? One ID, and it starts generating text. So in this case, I'm using a trick here, which basically means a 1 by 1, which is just 1, right? But it's expecting a tensor, like that, tensor structure. So in this case, because I'm using zeros, I'm giving it the ID 0. Remember that you don't actually give, you can't give a transformer words, you give it integers, right? The equivalent number, etc. That's how it was trained. So this ID exists it's a 0. Then it generates this text. What do you guys think? Do you think it sounds like Huck Finn? Okay. So read it. I mean, that's supposed to be from Huck Finn. Then I tried another example here where I give it a 1. So it's another ID to start on, okay? And so it starts, and they're different, right? So they're different sentences. So basically, you give it an ID to start with, and then it uses that as the input, right? And then it starts generating a new token, and then that gets added, and it generates a new one, and it keeps doing that to generate text sequentially, right? That's a GPT. But something like ChatGPT, actually, we have learned that we give it questions and it gives us an answer, right? Well, that's the idea then, is just, if I can give it a 0 and a 1 and generate text, what if I gave it a whole sequence of IDs and then it generates text based on those? Well, that's ChatGPT. That's, you give it a question, it just continues whatever it reads, and it keeps writing about it, right? And so this is an example of that. So notice now, this is Huck Finn, so I said, where is Huck, right? I'm prompting it. This is usually referred to as prompting. And so then I do the encoding here. And notice that when I do the encoding, I get this sequence of IDs, right? These are the IDs that I'm feeding this GPT. So now it should continue to generate from that. Does that make sense? Because that's what transformers do. They look at all the previous tokens to generate the next sequence of tokens. Does this make sense, guys? So in the previous example, I did 0 or a 1, right? And that's just, but in the paper, it says to do that. But here I can then, I want to start thinking like ChatGPT or those things that answer questions and answers, so I can give it the whole thing. So I give it, where is Huck? This gets encoded. I get the list of IDs. Now, one thing that you do have to do is you have to change. Notice I did this, and this is a 520 thing, right? You guys remember this one, right? View just means reshape in PyTorch, okay? Here and now and then you have a little bit of a concept from 520, but otherwise pretty straightforward. So just use this. I also did this. I think the encoder does this in NumPy. And remember that the other thing that we learned is we can't tie NumPy to PyTorch, right? So it's got to be a PyTorch tensor. So here's a NumPy, then I make it into a torch tensor. You specify the data type, long, the device, you have to tie it to the GPU, right? I did this on my GPU, and then you have to reshape it basically so it's not just like a one dimension, but it's a two-dimension thing, right? Row and column. So you may be able to give it several rows, right? That's kind of the intuition that I get from this. This might be batch size, right? Yeah. So anyway, so you see now this is a tensor of the sequence of IDs. And so now that should be new context, which goes in here. And now we're going to predict the sequence of tokens. So effectively, I can now ask it questions and get answers. Are they going to be good answers? Not guaranteed, but this is question and answer. So notice that when it you give it the new context and it does the generate, right? Then I get the generated text, and then what do? I decode it. Remember, this is like the tokenizer in reverse. And now I print it out, and notice that the question that I asked is there. Where is Huck? And then it's saying something. So what do you think? Is it answering the question? Why doth you know? So I know that didn't want of kind of. For anything, I reckon. What do you think? Keep in mind, this was trained on one book, right? GPT-4 was trained on all the books, all the internet, right? This is just one book. But essentially, everything else is the same, is my point. So the more books we gave it, the better it should be. Now, this actually underscores another thing. What would be better, GPT-2 from HuggingFace or this? HuggingFace, right? GPT-2 was trained on many books, many web pages probably, right? I think Wikipedia, things like that. So it's got a lot more knowledge about things. It's not call it knowledge, but relationship between words. Whereas ours just learned from this one story, okay? Now, the whole point of this homework is obviously to understand the code, but also to see, okay, if I give it one book, it does it in less than 20 minutes, but it's not great. If I gave it 100 books, it's hours on a GPU, right? So then what do you need there for this, for you to scale up? You need not just one GPU, but multiple GPUs distributed so that you can send the job to multiple GPUs, right? And then you can give it more books and it gets more training. And then the grammar starts to sound way better. Keep in mind that here, the tokens are actually letters. They're basically just letters, the 26 letters or so. Something like GPT will use something called subwords, which is an equivalent of like a syllable. But it's not actually a syllable. It creates its own syllables, if you will. Questions? Anyway, so this is, just wanted to emphasize this idea of how you give it the questions and the answers, right? Mechanically, you can see it right here, right? The GPT is just literally made for that, right? You can give it one ID, or you can give it a whole sequence of IDs. Like, you can think of it as just like that. I'm going to give it maybe 10 or 15 IDs, and it's going to generate 500 IDs after that. They're related, right? So then you're saying, if this is a question, this is the answer. This is a question, this is the answer. All right, so I did this example. If you want to figure out the math of how I did the calculations, I added this little code here just to test things out. But yeah, that's the example. In particular, I wanted to show how to give it questions and answers. Now, that takes us to the next step, right? So this is the homework, by the way. Are there any questions about the homework? You need to grab this Jupyter, pick your books or one book, run it, and then you're gonna show what it did, right? So these homework assignments are usually like a presentation type of a thing, very short. You come up here, you show what you did. You can print the PDF of this or something. You don't have to run it in real time, obviously. And you talk about, the hour, the hours or minutes, and if you use the CPU, how many days, So, yeah. So is this clear as far as the homework assignment? I haven't, again, given you a date for this, probably in about 2 weeks or so, once I know everyone has Scholar and it's working a little bit. All right, great. The project is also kind of related to this, right? But we want to do this in a more robust way. Okay, so the idea here is the following. I have shown you here in this example that you can take a sequence of IDs as input to the GPT, and you generate a sequence of IDs as output, correct? So that is essentially question and answer. I have the question here and the answer here. So I asked, where is Huck? And maybe we'll say that it didn't tell me where Huck is. I don't know if it at some point over the island, maybe, I don't know, right? So I'm saying that I only trained this with one book, Huckleberry Finn. So this is my very simple GPT trained from scratch. GPT-2 was trained on many books, many books, right? Many pieces of text. If I repeated that same exercise with GPT-2 and I asked it, where is Huck, or where's Napoleon? What prison is Napoleon in, for instance, or died in, or something like that? Do you think that GPT-2 would be able to answer that question? Maybe, maybe not. May not be very good. It may just say stuff about Napoleon and prisons in France, but it may not say that Napoleon died in this prison. You see what I'm saying? Because more data does not guarantee that it's going to be a good assistant for answering questions. That's actually a specific task like summarization or something like that. Do you see what I'm saying? So the model may be a little bit better at grammar, maybe a little bit better at tying Napoleon and prisons, but it's not necessarily going to be able to answer questions. So my point is there's an additional step after this, okay? So you guys are going to do for your homework a GPT from scratch. You could take GPT-2 right now and try to do this same thing, and it may not be able to answer your questions still. And so that's because all of this is the pre-training stage. So the pre-training is where you give it tons of books, tons of text, right? You need, as I said, distributed. So really, it's better to get the best GPT that you can. So for the homework, for the project, the mini project, I'm only asking you to use GPT-2, okay? Because that's actually easy to get to work, and it's small. I believe right now HuggingFace may have Llama, so you could fit Llama in there, which is Meta's equivalent to GPT-4 from OpenAI. You can try that, but it may be much larger, okay? So I don't know. And so, and also keep in mind, these models have like the 7 billion one and the 65 billion one. So some are bigger than others, okay? But for the project, just use GPT-2, okay? So what you're going to do for the project, and that's going to take us to the other example, is it's kind of the same idea. You pre-train, you did the pre-training, and you learned really quickly that it's really hard to do because you need a lot of resources, right? A lot of computing power. So hopefully this, after you do it, it's going to convince you that maybe I should grab a GPT or a llama or something that's already pre-trained, and I'm going to do the fine tuning. So what I'm trying to say is it is within the realm of something we can do. Fine tuning is something we can do, whereas pre-training, unfortunately, today in 2024 is not something that like one person can do on one GPU, because you want the model to be really good as possible. But also pre-training is not enough to create a ChatGPT that answers questions really well. It's gonna drift a lot. It might be very, like, grammar is gonna be very good, right? It's gonna sound like it's a person, but it's gonna start inventing things because, you know, it won't know, or it won't really know how to answer questions exactly. So you have to give it a little bit extra. There's an additional step called a fine-tuning step. Okay? All right. Anyway, so hopefully that transition made sense. We can always come back to it. All right, so let's go back to the Brightspace. Okay? So here on Brightspace then, so we've covered now the GPT. I'll come back to those, but you know your homework, right? I need to create the link and all that. Now we're going to get into the mini project, which is these two things, RLHF, and then this will be the link for you to use. So I already worked on this. So what is RLHF? It's a new concept, kind of after transformers, right? But it's not a neural network architecture. We're still using just a GPT neural network. It's just now a technique for training. So RLHF stands for reinforcement learning through human feedback. It's a complicated process, but basically it's what you're using to go from GPT-2, which is not so great at answering questions, to ChatGPT, which you give it a question, a prompt, and it gives you an answer, which is astonishing. That sounds like, oh, wow, this ties in. Do you guys see that? Does that make sense? All right. So this will also be a paper. So reinforcement learning is basically something that was used a lot in games. Okay, so you would create a neural network, which is an agent, and you would have that agent play a game. Let's say chess, for instance, right? So in chess, first of all, it's a two-dimensional grid, right? And so you move a piece, and if you kill the queen or the rook or something like that, you're told you're doing well. So that's called a reward. The game itself can give you a feedback saying the move you just took is good. Or if you move your knight and it gets killed by some other piece, then it's going to say that was a bad move, because the game knows the rules, but that's a feedback. So the agent, the neural net, gets that feedback and adjusts the weights accordingly. Does that make sense? That's reinforcement learning. We will cover, so you can see reinforcement learning after this, as it's one of the topics I haven't covered in 520. So I'll cover this idea. But reinforcement learning is, so then somebody thought, okay, that's really great, right? It became very popular when something called AlphaGo came out like 5 years ago or more. And it was basically how a neural network was able to play the game of Go, which is like a type of chess, but a different kind. And the model, the neural network, defeated the champ, so the human champion of that game. So that was really great to use that approach. I take a step, I get a reward because I know the rules of the game. And that's the feedback to the neural network. So it's almost like, think of, you have images, right? MNIST images, and then you predict the label, but you know that's a 7. So that's the feedback to update the weights. With reinforcement learning, you're in an environment, the agent just has to select an action, you know, where to move a piece, and after moving the piece, you get a reward. Got it? Okay. So that's really great for AlphaGo. That's really great for games, but how do you take that to the next level? Because not everything is a game. It's great if a problem can be modeled as a game, but not every problem can be modeled as a game. So there was a classic paper, the RLHF paper, before transformers, that is also an important paper that I'll post. And basically somebody said, okay, that's really great. Reinforcement learning for games is great. But what if I want to teach a robot to dance salsa? How do you encode that into a game? What rewards do you give for a move? Right? How do you know that somebody is good at dancing salsa? Like, how do you know? Do you measure the ratio of the movement of their legs or the speed, or how do you know? How do you know that somebody is good at dancing salsa? And not just that, but then write some code that gives rewards based on what it sees. How do you do that? Do you see that so how do you do that basically? So it works for games, but how do you apply it to other problems? So the solution that they came up with is this idea, reinforcement learning through human feedbacks. Well, and this is nice because it gets at really the power of neural networks. Neural networks can learn anything, right? So we don't have to code how to give the rewards. Instead, the idea is you just train a neural network to give rewards. It has to learn how to give rewards. And how do we train the neural network? Actually, the solution is very simple. While we don't know what is good salsa dancing, according to the paper, we can't really describe it. We're really good, humans are really good sometimes at looking at something and looking at another thing and saying, nah, I like this one better. You see that? And that's the solution. That's the human feedback. So what they did is, or they proposed, is that they had a robot trying to learn how to dance salsa in this environment, the agent. There was a neural network. So keep in mind, there's a second neural network right now, right? There's the agent that takes the actions of how to dance, and then there's the agent that gives the reward, because we don't know how to write that as in games. So now what has to happen is the robot in this case dances a little and saves a video. Then it dances a little, saves a video, and it dances a little and saves a video, shows those three things based on different weights to the human. And the human looks at all three videos, plays this one, plays this one, plays that one, and says, I like this one better. That feedback goes back, because if you think about it, to produce this video, you had a set of weights. To produce this other video, you had a set of weights. And to produce this video, you had a set of weights. The human liked this video. Therefore, these are the better weights. Do you see that? That's how that translates. Make sense? Now, to take that to another step, right? We have a human looking at three videos. And the human just needs to say 0, 0, 1. Because I like this one and I didn't like the other ones. The model, a neural net, has to do something similar, right? Predicts a vector, and initially it might say 1, 0, 0. But the human said 0, 0, 1. So effectively, you have your labels and you have what the model predicted. That's just standard, right? Cross entropy, right? And you calculate the weights. So the reward function, which is a neural network, now can learn from what the human predicted. Is that clear, guys? How that works? Yeah? All right, so that's the idea, right? So the human doesn't have to look at the robot trying to dance salsa all the time, right? In fact, the human just has to look at some cases. You repeat this several times, and then you train the neural network to predict in a similar way to the human. So out of 100 times, the human says, this one, that one, and then the neural net initially gets all of them wrong. But over time, 80% of the time, the reward function is agreeing with what the human is saying. And there you go. You've got a trained reward function, and that's how it works. And then you can apply that idea to any problem, basically. That's reinforcement learning through human feedbacks. Consensus is this is how ChatGPT was trained. So now let's take it to, let's work. So remember, all of this of robot dancing salsa is in simulators, is coming more from like games and things like that, people that were doing that kind of work. But the idea is really good. And then OpenAI probably thought, okay, let's take that idea and use it. So they've got a GPT-2, which you guys have now. Then they did GPT-3, 3.5. I think there's GPT-4 now, right? But it's not available, like it hasn't been released or something.
Is that the one where it's available to pay for it, or is 3.5?
Oh yeah, you might be able to get to it through the interface. But if you want to download it, I mean, yeah, you wouldn't be able to download it, right? So they've kept that proprietary, and that's why Llama then says, okay, we'll create our own. And so they made Llama available. So Llama is supposed to be, I don't know if GPT-4, but at least 3.5, I assume. I haven't checked on that. So that's where, so OpenAI is at GPT-4 or whatever it is, but it's equivalent to your GPT-2 in a sense that it hasn't been fine-tuned to be really good at answering questions. So it's still, you ask it, what was the question? Where was Napoleon? What prison did Napoleon died in? Something like that, right? So we wanted to say, oh, Napoleon died in prison in Corsica or something, right? I don't know exactly. But so that's what we want. So the GPT-4 may still drift, may still not be able to answer that so well, right? So that's where the fine-tuning part comes in. So I asked you guys then, knowing everything that you know, imagine you're an OpenAI, you know about this robot and the feedbacks. How do you do this? How do you take a GPT-4 that is like a GPT-2? The text is getting better, sounds more grammatical, right? But when you ask it specific questions, I don't know, a question. What's another question that's not the Napoleon one that might be complicated? What's going to happen in the election in 2024, something like that, right? And so it's going to give you some description that's complicated, right? So it may not be very good at answering that because it's only a GPT-4, right? You want it to be more precise you give it a question like I showed you now, and you want to get really nice answers. What do? You've got a GPT 2.4. You know of this idea of RLHF, reinforcement learning through human feedbacks, that I've described to you. What do? That's your project, by the way. Yeah, go ahead. Daniel.
Right now they have like the thumbs up and thumbs down. Like if you like vote down, they'll change its answer. Like where the data.
Okay, all right. So that implies you asked it a question, it gave you an answer, and you liked it or you didn't like it. That's correct. And yeah, you have this platform. You have this platform where people are doing that, so you're collecting that data. So what if you didn't have the millions of people that are using ChatGPT right now? And it's really expensive for OpenAI. It's going to cost you just to create 100,000 of these. It'll be very expensive. So how could you automate this a little bit? Going back to the idea of RLHF, right? So remember what I said. You can't, the robot dancing salsa, this is similar to that. The robot dancing salsa, right? You can't have a bunch of humans looking at videos every 2 minutes, right? And saying, oh, this is good, this is bad. That's really expensive. Do you guys see that? Also, it may not be necessary. You're wasting $1 million there. It's not necessary. That's actually the thing. Automation, right? So what do? Instead of having humans doing this all the time, what makes sense? Remember in another AI, right? Exactly. So the reward that in reinforcement learning that was very easy to do with games, because it's just, you know, if you move the piece there and the queen dies, you know, that's it. You know, that's easy in games, but it's not so easy in like reading text, for instance, right? And so, yeah, you can have humans, or you can have fewer humans do that a few times of basically rating, and then train a neural network to do the same job. Do you see that? Making sense? All right, so let's think of this pipeline, because this is what you guys will have to do, and then I'll show you the code. So what do you start with? A GPT, correct? You'll have a GPT, in this case, GPT-2. I've shown you already, you give it a sequence of IDs, that's the question. It's going to generate a sequence of IDs, that's the answer, correct? What you want to do is you want to make the GPT, in a clever way, make better answers. Right? So create 300 prompts. Right? Feed them to the GPT and it'll generate 300 answers. Right? And then you rate them, right? So you're going to say, this is good, this is bad, this is good, this is bad. And you're going to use that information to update the weights. Do you guys see that? So we can use this. One thing we can use from the salsa dancing robot is, you know how it would dance and it would generate a video and another video and another video, and then you just said, this one is better. Here, this is even easier, right? Because you give it one prompt and it generates this answer, this answer, this answer. A human looks at this one, and that one, and a human could say this one. Do you agree? Yeah. In fact, for the homework or mini project, you only have to do that for 2. So the key thing is you have to generate 2 so that you say this one is better over this one. So think of it in a sense as you're nudging the weights in one direction or the other direction. Doing that enough and you get better answers. Make sense? Yeah. All right. So can we give, so what we need to do is we give the GPT-2, let's say, a prompt, and we have a function that is going to generate 2 answers. A human would look at them and say, this one or that one, gives a score of some kind, right? And then after that, that information through the reinforcement learning algorithm is used to update the weights, right? So that's the idea. But we still have one problem, right? Which is we don't want the human to do this all the time. Instead, we want to automate that process somehow. So that's where the reward function as a neural network comes in. Now, in the example I'm going to provide, it was actually even easier because they just use one of these BERT models that the problem is for sentiment analysis. So basically, they just use one of these BERT models that can look at some text and gives a value, such as positive or negative. So that's the reward function in this case. So the example I'm giving you does not have a reward function that you have to train, basically. What I'm saying, we use a already trained score. Now, did we state at some point that a GPT can read text? Well, let me ask you this. Can a GPT read text? Yes or no? It can't read text? Oh, right. So, I mean, yeah, you take text, convert it to integers. But if I give it a sentence or I give it a paragraph to a GPT, could you say it's reading it in a sense? Well, now let's think of this problem. Sentiment analysis. I give you some text, right? The GPT, and the GPT issues a value that says positive or negative, right? Is that possible? Yeah. Is that not reading? If you give me a paragraph and you tell me to read it and tell you if it's positive or negative, I can do that. I just read it and positive, 0.5, 0.7. And a GPT can also do that. You see that? So it can read in a sense, right? I mean, obviously it's not reading as humans define it, but it is taking in an input of text, convert it to IDs, and then issues a score. And that score can be used as a reward. Okay? So the example I have here, we have like 10 minutes, so I'll go over the example and then we'll come back to it. It's basically about that. So it's a GPT-2 already trained to do movie reviews. So any text you give it, it's going to try to review it as a movie. And then there's another GPT, a BERT, and that one is like the sentiment analysis one we looked at. It looks at the text as an input and it says if it's positive or negative. And that acts as a reward function already trained. So then we have a GPT-2. You give it a movie, you say something, a prompt about movies probably, and it issues a review. This movie is really terrible. This movie is action, but I didn't like it. But you run it through this cycle of reinforcement learning through human feedbacks where the BERT model is reading all, it generates two, right? It reads both and it says this one over that one, and that is used as feedback, right? So what's going to happen to this GPT-2, at the end of this training? It depends on the goal, right? So if the goal is, for instance, here, we can say that we're evaluating if the text is positive or negative, right? So what can we do with that? Could we make the text, could we make the GPT maybe produce outputs that are more positive or outputs that are more negative? Could we do that? Why?
So during the feedback, it will give more value. Like it will always choose the positive ones. Most of
If we want, yeah, right, exactly. It looks at text and it predicts it as positive or negative. If we want it to favor positive somehow, then we could give that feedback because we're already giving the score. So in a sense, the model would be penalized every time it produces something negative if what we want is for that to be positive. Do you see that? So eventually, what would you expect about the weights of the GPT? They would be shifted in such a way that it would start to learn to produce more positive text. Does that idea make sense, guys? That's the same idea of ChatGPT where you want better answers because the data that you have is about a reward function that looks at two answers and says, this one was better than the other. Got it? See the relationship there? So you can adapt that to lots of things, I mean, with your creativity. Okay? All right, so let's go over the example that I have here, and then we'll wrap up with that. And we can come back to this topic again. This will be your mini project, okay? The code works. So I've done an example that works. This took me 2 hours on my GPU. So this obviously is a more, that's why it's a mini project. Start working on it. Now, the first thing that you should do that I would recommend is just replicate my results. Okay, replicate my results. And then you're going to have to think of what you want to do. I just took this from HuggingFace. Is their own example. Okay, this is all HuggingFace. So it uses the TLR or TRL. I think I inverted those letters. So it should be Transformers Reinforcement Learning. It's a library that they've created for you, for everyone to implement reinforcement learning through human feedbacks in a very HuggingFace way, so it's easy. Okay, so the idea is, basically here, you have a query. The movie goes into the GPT, and the GPT gives the response. Really great, really bad, whatever. So that's what the GPT-2 can do right now, because it's a special GPT-2 called GPT-2 IMDb. It's already fine-tuned to the IMDb data set. But then in the reinforcement learning part, now the query and the response are concatenated together, right? The movie is really great. And that text goes into a DistillBERT for emotion, sentiment, right? And it looks at it and it's going to say, oh, I think that's positive or I think that's negative. That's the score that we're producing. And just with that, That's enough feedback to nudge the weights towards generating text that's more positive or negative. You could also take this example of you generate neutral text and then you make it more Republican, more Democrat, right? Or you could make it more, what's another example? More Shakespeare, more South Park, or you can make it, you know, this is what I want you guys to do. It doesn't have to be very complicated. I just want you guys to nudge your GPT in one direction or the other. Now, obviously, you can train your own reward function, and I leave that to you guys if you want to do that. But this solution just took a HuggingFace model. So there may be other models, other BERTs or whatever that read text, because we've established they can read text, and they issue a score. That's the key thing. Is it a score of how good the summarization was, or is it? So definitely this part, if you find a HuggingFace model that could serve as the reward function, use it. Because training one would be a little bit more challenging, but you guys probably can as well. Got it? Does that make sense? All right, so just to kind of wrap up in the 5 minutes, this is the example. You can start playing with this right now. You will need to install the transformers library and TLR. You can see that there they are. This uses something 1 dB, which I disabled, but it might be a good thing. It's for like keeping track of things. You just have to log in to something, and I didn't want to log in, but you can enable it back. It does require Python 3.8 or greater. These are all the libraries that you probably need to install. It ran, as I said, it ran on 1 GPU. Notice it's got the basic transformer things here. It's got some the config. This uses the GPT-2 IMDb. So for your mini project, you need to choose what type of GPT do you want. Do you want a basic GPT, plain vanilla GPT-2? It might be GPT-3. Maybe, I think now Llama may be available. I just don't know computing wise. So there's a lot of versions of GPTs, right? You have to define for your problem. You definitely need to have a model that does something, and then you want it to be better. So you need to use this approach to be better, okay? And you need to find a reward function. So those are, so a data set, etc. This loads some data. So remember, loading data is going to be different for everyone. So keep that in mind when you choose your project, because it could become harder. But it is text at the end of the day. So here's the example of how to load the GPT-2. You can see that there. Notice it uses auto model for causal with value head. So that's that idea. This, don't worry about it. This is the actual implementation of the RLHF. There's a lot going on there, like a lot. But HuggingFace has made it so easy that you just invoke a function and give it like the config, the model. You need a reference model. We'll talk about this later, but it's just the original model, and then the tokenizer and the dataset, okay? Load BERT. BERT is your reward function. So in this case, notice it's the pipeline sentiment analysis. We did a simple example of this one, and notice it loads, I guess, yeah, DistillBERT. That's what it uses for sentiment analysis. And you can see an example of that. This movie was really bad. Run it through the pipeline, and it says negative or positive. So it's more negative, right? Here, the movie was really good. Positive is higher. Got it, guys? Any questions about this part? Okay. Then you've got the arguments here, the full parameters, and the training loop is here. So it goes through that. And I did get some warnings when I was running this. This is, I was reading reinforcement learning has this check so that the model does not get unstable. So it's fine. Okay, it ran for 100 iterations by default. So I'm assuming you guys will use a lot of default parameters. And then here's the output. We'll wrap up with that. Now, the one thing I don't have in here, remember I said, is a metric. I didn't implement like a metric, like the, which is really the appropriate way of measuring things. Instead, this just provides a nice table. So it's a more of a qualitative analysis where we have the query that we gave it, and then we have the response before RLHF and after RLHF. So this would mean this is the original GPT IMDb that just gives movie reviews. And this would be so it makes them more positive. Do you guys see that? All right, so now you guys, so here's an example of why I think it works. Yet another forget, right? So this is like random prompts, but if you notice, here's the answer before, suggesting it has had a fantastic effect on, and then after is about, this is a great movie. Which one's more positive? Difficult, later one, okay. What about this one? So Borix and Suggestive Bad Dead Persons is a wonderful movie. Which one is more positive? Now remember, it's GPT-2, so it's not going to have the precision of GPT-4, right? Don't expect ChatGPT results here. Maybe if you use Llama, it might be better, but it's still GPT-2. So which one is more positive? Second, all right. Let's look at this one. Bad movie, there are two. Brilliant man, he had a. Which one is more positive? Second. In the name of justice, let me rephrase. This is a wonderful film. Do you guys get the point? Hopefully you see the point, right? So the point is, it's a GPT-2. It's not going to have perfect grammar. It's not going to be as impressive as GPT-4 or Llama or ChatGPT, but it is generating text. You give it this text, it generates these. You change the weights, you nudge them in such a way that after it's more positive. This is kind of what in your mini project I would like to see, at least. Okay, that's it. So, start replicating this. I think it does print some statistics, and then you can even save your model. And if you want to create an account on HuggingFace, you can even push your homework to the HuggingFace hub. Okay, so anyway, you can start working on this one. Please try to replicate the results. Start thinking about what problem you're going to tackle, and you may be limited by the models available on HuggingFace. I would definitely recommend to start there instead of trying to train your own. Okay, all right, that's it. I'll see you guys next week.